Hello, welcome to week 5 of cryptography and data security. What we're going to be jumping into today is basically giving an overview of how do we keep secured in the scope of the internet. We we've talked about encryption. We talked about how it works. We talked about hashing and how it protects integrity, how digital signatures help improve trust. But now we're going to look at a situation where the basic problem is this. Before we look at solution, let's reinstate. Okay, what we have the problem is on the internet is that parties have never seen each other. They never met. So it's not a matter that you're basically having a conversation with someone you trust. The networks are not private. And when you're on a network, everybody and their mother and sister and brother is also on that same network. And attackers may be listening. It's an ideal place to get information as it's crossing the network, across the wire, somebody picking that up and getting access to that information. So week 5, this is what we're going to talk about today, is focusing on how systems solve this problem safely. How do we get around this? Okay, the first thing is I want to talk about is the Diffie-Hellman key exchange. The Diffie-Hellman key exchange is a method that allows two parties to, number one, create a secure secret key, and two, over an insecure network without ever sending the secret key itself. So that's interesting. So this is one of the most important breakthroughs in cryptography. How can I create a secret key and over the internet over an insecure network? So I'm getting the secret key. How do I get it over an insecure network without ever sending the secret key itself? Okay. So conceptually, here's how Diffie-Hellman works. Here's the idea. Both parties agree on the same public information. When we talk about public key, private key, each party combines that public information with a private secret. The party exchanges a computed value. Both sides independently arrive at the same shared secret. An attacker may see everything sent across the network, but cannot compute the secret key. Okay, why is Diffie-Hellman secure? Diffie-Hellman basically is secure because, number one, certain math operations are easy to do. And so back into the realm of mathematics in solving this particular problem. But it's extremely hard to reverse. Remember our classic, we want to make it easy to encrypt, but hard to reverse once we encrypt it. Okay. Okay, so even if the attacker records the exchange, they cannot calculate the final secret key. The shared secret is then used with symmetric encryption, okay? Symmetric encryption, such as Advanced Encryption, AES, Advanced Encryption Standard. And we use that in order to get the information. Okay, what is the digital certificate? A digital certificate is a digital document that, one, proves the identity of a website, server, organization, and binds an identity to a public key. Okay, so when I'm going to a website, okay, and I'm thinking that it's Home Depot, okay, there has to be a digital certificate that verifies that where I'm going is actually Home Depot. Okay, that's where the digital digital certificate comes into play. Who am I really talking to? Okay, that certificate proves that out. Okay, so what we have is a certificate authority. A certificate authority is a trusted organization that verifies identities and issues digital certificates. So for me to go to Home Depot would have to have gotten a digital authority from a legal company that gives out digital authorizations. With that certificate, I now know that when I'm going to Home Depot, that it's a valid URL or valid location. So it verifies identities, issues digital certificates, Example includes companies that browsers already trust. If a certificate authority signs a certificate, their company believes this public key belongs to who it claims to belong to. That's the purpose of that authority company, is to make sure that that verification takes place. Okay, so now we have what is a public key infrastructure, a PKI. Okay, a PKI is the entire system that one creates, manages, distributes, and revokes digital signature. Okay, so the public key infrastructure is that company we're talking about. When we talk about the certificate authority, here's what they do. They create certificates, they manage the certificates, they distribute the certificates, and they revoke certificates when, say, a company goes out of business or is no longer a viable entity. Public key infrastructure includes, certificate authorities, digital certificates, public and private keys, trust rules built into operating systems and browsers. So that is their purpose. Their purpose is authentication. Okay. How trust is established using the PKI. Okay, a website presents a digital certificate. Your browser checks who issued it. The browser verifies the certificate authority. If trusted, the browser accepts the public key. Okay. I know you've probably been just thinking back. You might have been on the site and something pops up that says, "Hey, this certificate for this company has expired." Okay, do you really want to go to this location knowing that their certificate has expired? So that's where this comes into play, and that check and the interchange is being done between who I'm trying to get to or who's trying to get to me. And then the browser checks as far as the certificate authority and making sure that where I want to go is actually a valid location that has been verified. Okay, this happens automatically when you visit a secure website. Nothing you have to do, it automatically happens. Then we have Kerberos. Kerberos is a network authentication system designed to verify the user's identity, provide mutual authentication, avoid sending passwords over the network. Kerberos is commonly used in corporate networks. Big companies use Kerberos. University systems, okay, like Carolina. Okay, enterprise environments. Okay, Kerberos provides mutual authentication. Mutual authentication means that the user proves who they are in the server. The server also proves who it is to the user. Kerberos works using a trusted central server, issuing time-limited tickets. It means they expire after a certain time, and allows secure access without repeatedly sending credentials. Okay, Kerberos prevents password exposure, reduces replay attacks, and centralizes authentication control. Again, you notice we're not really getting into really deep how physically it works. Okay, because right now what we're more concerned with is what are the tools that we can have that will protect that authentication process. Okay, so that's what we're going over. In your lab, you will get more deeper into maybe, and it's really not even looking at the internals, okay, of the particular processes, but taking information, running it through, and see what happens when I do have a bad certificate, when I do have a good certificate. So again, your project will be kind of emphasizing that part of it to get the day-to-day nuts and bolts without getting too deep. Again, I will save that for an advanced cryptography class, okay, as far as getting into the details of the particular processes themselves. Okay, transport layer security and secure socket layer. Transport layer security, back a few lessons ago, weeks ago, we talked about TLS. Okay, I said, okay. I wasn't going to go into it, maybe want to look it up, but here's where we basically dive into. Traffic layer security, often called TLS, and secure socket layer, SSL. Both of them are probably pretty prevalent acronyms that you've heard and when talking about security. Secure data while it's being transferred, protect communications between the browser and the server, Secure sockets layer is a older version and it's no longer considered secure. Using SSL is one of those situations where this is where we were, okay, but now this is where we're going, and this is how we got there because of SSL. Okay, the transport layer security is more modern and a more modern and secure standard. Okay, how transport layer security works, high level. Transport layer security authenticates the server using digital certificates, establishes shared secret keys using a key exchange, encrypts data in transit, protects integrity and confidentiality. This is what creates secure web connections, is having these four items basically being the forefront of what we need to have in place. Okay, why transport layer security matters? Transport layer security protects login credentials, credit card numbers, personal data, private communications. Wherever you see HTTPS, okay, the web address, then you know that transport layer security is being used. Okay, so in summary, by the end of the week, you should understand Diffie-Hellman. You should know what we're talking about, identifying digital certificates. You should know about the public key infrastructure, establishes trust. You should know about Kerberos, provides mutual authentication using tickets. And then you should know about the transport layer security and how it works, again, on a high level of how we fit these things together for data security. Okay. Have a good time with your project and kind of reinforcing these concepts that we talked about from communications. And we will see you either later this week or tomorrow or today, depending on when you're reading this. But we'll have a good time, and we're prepared for next week for week 6, going down the home front, going down the home front, going down the final stretch. Okay, again, preparing for week 6 and week 7. Have a good one, everyone. Bye.